I'm Anil Kumar, and in this video we will further explore how composition of functions help us to solve real life situations where rotation of an angle is involved. And whenever we have rotation of an angle, we know we have to apply trigonometric ratios. In one of our videos, we have already discussed an example where we said that let us say we have an angle in which there are two particular arms and length of one arm is given to us. Let us say we'll call at present this as b centimeters, and let us say the other arm is, we'll assume it to be a centimeters, a slightly smaller than this, and we'll call this as a centimeter long. And we are assuming that the other this is a fixed arm, the other arm is moving, and we know the rate at which it is moving, right? So at another instance of time, let us say the position of this arm is kind of here, right? So let us say that is the position, and we need to find the area which is being swept by this particular revolving arm, right? So how can we find that area? So that is a problem which we'll look into now. Well, the concepts in the previous example, what we considered was a triangle, right, joining this point. Now in this particular case, we are not talking about a triangle. We are talking about the sector, the circular path, which the smaller arm is sweeping across. Do you understand? And what you need to find is the area or the rate at which the area is changing if we know the angle of rotation, the rate at or the angular velocity of the second arm. In that case, how are you going to solve this question? So let this be the question for you. And obviously, what we're trying to find here is a relation which is area of the sector in terms of theta. That is what we are trying to find, right? Now, to give you a hint about it, what we have is we have a circle whose radius is a, right? So a is the radius of the circle, and therefore you can always write area in terms of the radius r of a circle as pi r squared. Correct. Now, in case we are interested in the area of the sector, so area is, this is the area, right? So area of the sector, depending on the angle of rotation, we can always find that particular area as pi r square is the total area, right? So if I multiply this area, this is total area of full circle. But if the angle theta is beginning to change, in that case the area of this sector is going to be theta over 360 degrees, right? If you are doing it in degrees. So that becomes a relation which is going to relate area in terms of angle theta for known radius, right? So if I know that the radius is a, then I can write this as pi times a times theta over 360 degrees. So what I've got here is I've got a relation in terms of the angle theta, right? So that is how what you can do is you can change your variable, and all this happens with the help of composition of functions, right? So let me take, now you have understood this example, how to relate area of a sector with changing angle, right? So that is kind of introduction to rotation and how trigonometric terms can help you find a relation which can help you solve the question, right? So we are not solving any particular question, but we are understanding the concepts in this particular video. So that is the first concept, and now let's look into another concept. I think that is going to help you to understand many situations. Now we have kind of a beacon, or you can say a searchlight is located on a shore. Let's consider this to be a shore, and let us say that there is a searchlight somewhere here, and this searchlight is scanning the shore, right? So it is just moving all along the shore at night, let us say, scanning the shore for security reasons, right? So that means we know the rate at which it is moving, it's revolving with an angle theta. And let us assume for the time being that this searchlight is about 300 meters from the shore. Let's say this distance from the shore is 300 meters, right? And it is scanning the shore. So what we need to find is how fast does this beam of light along the shore at any point on the shore is moving. That is what we need to find, right? So how do you relate that? So that is a question which we need to answer here. So we need to find along this shore, let us say there is any point along this shore. Let us consider this particular point, for example. Now, if the searchlight is 300 meters, minimum distance is 300 meters from the shore, then at any point, when will it come the next time, or how fast is it sweeping at that point, or for that matter, any point on the shore? That is the question which we are interested in. Now, to answer such a question, what are we required to do? We are required to find a relation between this distance x and the angle theta, right? That is what is required. Now, in such a situation, what we can do is, we know x is the opposite side of theta and adjacent side is known to us, so we can write a relation which is tan theta is equals to x over 300. So we have a relation, and this relation relates the distance x as 300 times tan theta. Now, since we know the distance with respect or relation of distance with respect to the angle, now if I have rate of change with time, do you understand? If I have rate of change of x, then that will be equal to, let me write in bracket, 300 times rate of change of tan theta. Do you understand? So if I know the rate at which this light is revolving, then with the help of this particular equation, I can find the rate at which it is sweeping any point along the shore. You get the concept, right? So the idea here is just to give you the concepts, and then these concepts are going to help you to form a relation which can be further explored with the soon knowledge which you're going to learn in calculus to find rate of change, right? Or in advanced functions to find instantaneous rate of change. But the first question always will be to get the basic equation. Now, given such situations, we can actually relate distance with angle of rotation, and solve our questions. Now, this kind of equation is also very popular when we are talking about a beacon which gives you a beep and it is trying to locate the airplanes. In that place also, it is very important. At airports, there are searchlights, and those are the examples where this equation, which seems to be very simple, can be applied to solve the problems. So I hope with this you understand that there are so many ways of relating distances with angle and angle of rotation and forming a composite function. It helps to solve problems. I hope this knowledge is going to help you to solve many questions in advanced functions and in calculus. Thank you and all the best.